Yes. So anyway, what we're about to say is that today's session is not going to be an introduction to FME, and it's instead going to be a deeper dive into what actually is 3D. I know lots of folks that are tuning in will have had much experience with 2D and 2.5D CAD and GIS, and they're used to lines, polygons, maybe some elevations floating around, maybe a surface model now and again. But this is kind of tearing off the costume and looking inside to see what actually constitutes 3D data. What are the various aspects of it, and how can you make that something useful?
Yeah, so I guess the question is, why are we doing this? There's a few reasons. We're adding more 3D capable formats. We're moving into the BIM market where we work with 3D files like SketchUp and 3D PDF. So these formats use a type of data structure that generally isn't found in other pieces of applications. And these are the type of structures we're going to be talking about today. Yes,
but we thought we'd start off by something light. And Dave, why don't you click that and get it queued up? fme.ly/pumpkin. Let's, what do you want to change that to? Dr. Tongue. Whoop, I think you spelled it wrong. There's no U there. So this is a really practical use of all the different things we'll be showing today. Yeah, let's go ahead and see what happens. If you can go ahead, I can invite everybody else to now try and go there and carve their own pumpkin. But this is actually FME underneath that's running a workspace that's using a lot of the principles that Dave is going to teach us about throughout the day. Dimitri set this up. And in fact, some of you that might want to, you can download the template for this. And this is actually going and carving, creating 3D text. It's got a 3D model of a pumpkin. It's carving it out, and probably everybody else is doing it right now. So we might have to come back and see.
Okay, we'll let that run.
Yes, but anyway, you can go ahead and try that and see what's going to happen. In the end, you should get a 3JS, which is one of our many output formats.
Yep.
Ish, I guess.
That one.
Kind of.
Not quite promoted to be a real boy yet.
Yes.
But it's getting there.
It's coming. So anyway, we'll see when it comes there. So anyway, Dave, you want to walk us through the agenda? Sure.
We're just going to go over the basics of the 3D geometry, including the geometry types, the structures of these geometries, including sort of a deep dive into the nested hierarchical structures you can get in FME. We're going to deal with appearances, which are like the textures on your 3D formats, because let's face it, what's a 3D object without a little color in it, right?
Mm-hmm.
And then we're going to just cover, on the way, we'll cover some of the transformers that are used to deal with this type of data.
Right.
These are some of the formats that will give you the true 3D objects. PDF, as I mentioned, Autodesk FBX, Collada. The new one on the bottom there is Cesium, which we're all very excited about, and there'll be a little Cesium in the demo as well.
Oh, you're going to show us some Cesium today.
Yeah.
Yeah.
Okay, so here are the two types of geometries we're going to be working with today. As you can see, FME covers quite a range of geometries, but it's mostly the surface and the solid. Well, we got multi-surface and multi-solid down there, but they're just groups of surfaces and solids, so we'll stick with that. So the basic three basic 3D geometry types are your surface, which essentially is kind of like you think of it as a polygon in space, but it actually has a side to it, and it's got a I guess a 3D-ness to it. We have a front side, a back side, and an orientation in space. We have meshes, which are kind of a simplified representation of a surface made up of points and triangles. And then we have solids, which are true 3D objects. They have an inside and an outside. Now, we're going to start with the surface. The surface, we have several types of surfaces. The face is your basic 3D unit. You can group together faces into composite surfaces and multi-surfaces. And the difference between the two is a composite surface is the faces have to be connected to each other, and they also have to have a consistent front and back direction on the faces. And that's going to come into a little bit more importance when we deal with solids. Multi-surfaces are a little bit more loosey-goosey. They don't care. The faces can point one way or the other. It's pretty much just an aggregate of a bunch of faces. And that brings us to our first demo.
Is our web demo done yet, Dave?
Oh, let's have a look.
How can you tell? We have to escape.
I have to escape.
Ooh,
pumpkin.
Scary.
There we go. We have our Dr. Tongue, scary pumpkin.
Yeah, and can you zoom in on that thing?
Yes, we can. Whoa.
And you can go right inside it.
Really?
Yeah. Whoa. You can look out the back. There's an FME back there.
Cool.
And there's Dr. Tung from the inside.
Yeah.
So anyway, this is done with 3JS, and it is a very powerful way to create sort of modest size objects, 3D objects for looking at the web. Not scalable like cesium,
no.
but for pretty good scenes. And the navigation is spectacular. We're gonna have to do more with that in the future. Can we take the lid off, Dave?
I don't
No
think so.
way, we can't take the lid off, but oh well. Okay, so that's good. Well, that worked.
Yeah, yay. Cool.
All right, so back you are, and so you wanted to just walk. So we're looking at which one was it? Surfaces now?
Yeah, we're just going to do a quick demo for surfaces. So let's. So I'm just going to point out the different types of surfaces we have and what they look like. So we have a couple of pretty medallions. One of them is multi, one of them is composite. So we'll look at the composite first. And if I click on it, now this is your best buddy and pal when it comes to 3D geometry, is the data inspector and the feature information window. Because in here we can see the entire hierarchy of the feature. So we have a composite surface here. It's got a sidedness. This one's two-sided. It can be single-sided as well. You've got front appearances, back appearances. In this case, they're inherited. You have the appearance references on each face. Oh, sorry, missed a spot there. The composite surface is made up of faces. So we have a face here, we have a face there, we have a face there. Inside these faces, you have geometry traits. You have the sidedness of the face. You have appearance references on the face, and then you have the bounds of the face is made by an FME polygon. And on the face bounds, or on the boundary polygon, you have some interesting measures on here, FME texture coordinate U, V, and Q, and we'll get into what those are later. But that gives you the texture coordinates. So you can really dig down and see everything you need to know about your 3D feature here.
Now, imagining that I really don't know much about this, appearance is basically like an image or the color or the texture.
Yeah, we're going to get into that later.
Yeah.
But yeah, it's basically what makes the face, it gives it some color.
Right, and then you get, so what I really can take from this is that even though this is a moderately simple looking type of object, it is pretty complex. Yeah. There's lots of pieces brought together, and they're structured in a way that ends up creating what we're seeing. But it's not simple. It's not. This isn't your grandpa's old logging road CAD line.
No. There's like I said, there's a complex hierarchy involved, and that's the key to a lot of 3D stuff is hierarchy, and we'll see this as well. So here I have just a simple multi-surface, which is essentially two of these previous composite surfaces stuffed together into an aggregate. Right. Now think about multi-surfaces. Unlike the composite surface where everything has to form sort of a whole, multi-surface can be any old faces here, there, everywhere. Okay. So again, just for the folks back at home, if they aren't familiar with FME, when you started this process, you used FME Workbench, which is the other tool there. Yeah. You can just bring it up for a sec. There's Workbench. And that you were reading from SketchUp here. Is that what you were doing? No, this is just this FFS file. Yeah. I had to tweak this a little bit to get it into the format. Got it. So it was at one point, this must have been SketchUp because I saw those traits on there. Yeah. But you moved it to the FME kind of optimized internal format called FFS. Yeah. And then normally people create their workflows in Workbench, and Dave's going to be digging into that with kind of where data is coming from on the left and the blue things on the right, what happens to that data on the way by. And then in this case, you were just popping up our inspection tool, but often you would be writing to say 3D PDF or 3JS or something on the right-hand side. Exactly. All right. So next part of the lesson is? Next part of the lesson is meshes. Ooh. Now meshes are kind of cool. They're a very efficient way of storing your surfaces. So unlike before, we had that hierarchy of faces and composite surfaces and everything. Mesh just blows everything into a single layer, but it stores a lot more efficiently. And I'll show you what a mesh looks like in FME. So this place, we're just reading from a DEM file. We're using a tin generator to create a surface from that DEM file. And by default, the tin generator creates a mesh surface. So we'll just run this. It's about as simple as it gets in 3D right here. Pretty much. And we'll have a look at this mesh. So we can see that it's got a nice triangulated network here. Ooh. Got the 3D happening. But if we look, more importantly, is if we look at the feature information, we see that it says that IFME mesh, we're all good there, but there's no hierarchy involved. There's a vertex pool and parts. That's all you got, folks. So a vertex pool is all the vertices in this mesh. Every single point there is in this vertex pool. And then parts, these are the actual faces, if you will, in a mesh. So it tells you the index, the vertex index of each of these of the little faces in here.
Right.
But again, they're not individual faces. They are part of a whole.
Yes. So this is an optimized way of doing 3D.
Exactly. It's much more efficient to display. It's much more efficient to store. What it lacks is any sense of hierarchy.
Right.
So for simple 3D formats, we'll usually write to mesh, and things are stored as mesh.
Right. And so for GIS people, and if you've got some 3D-ish or 2.5D data kicking around,
Yeah.
the most likely thing you're going to create is a mesh like this.
Exactly.
True 3D comes from much more complex things.
Yeah.
And there's no color on that thing.
No.
But you could if you felt
could
like it.
texture, and actually you can texture the individual parts of the mesh.
Wow.
So it does, I mean, there does have a lot of the capabilities of the standard sort of face hierarchy.
Yeah.
Except for the hierarchicalness of it.
Yeah.
Okay.
So that's a mesh.
That's a mesh. Now our next geometry type are solids. Now we have three types of solids in FME. We have a box, which is our kind of 3D solid primitive, and it's not really good for anything. I'm sure we have a reason for it. But
Minecraft, maybe.
No, those are.
That isn't even
that's
then.
a point cloud.
It's for visualizing Minecraft.
Yeah, really, I don't know what it's for.
It's handy for kind of experiments.
Yes, there we go. Next is something a little more useful. This is extrusion, and what the extrusion is essentially a base face. So we have a polygonal object, or that it can be actually a polygon too, or a face, and it just essentially is an area, and we take that area and we extrude it. Oops. We extrude it in a direction, and that creates the solid.
So quite often, like with sort of these text things in FME, we use a text stroker, give us 2D text, then we extrude that up to get text as a 3D object. Probably that's what Dimitri does in that pumpkin example, is he extrudes that text. Again, text stroker gives him vector polygons, extrudes it, now he's got solid-y things, and then he can clip those out of an existing pumpkin, and off he goes. Now, yeah, exciting.
Now our last one is probably the most useful solid, and it's what we call a BREP solid. I think that's boundary representational solid. And essentially, it's a solid defined by a closed composite surface boundary. And for those of you in the 3D know, there's our traditional teapot.
I'm a little teapot, short and stout.
No, please.
Here is my handle. Here is my spout.
Okay, different teapot. So we have that, and this is essentially, we have a surface that encloses the solid. And as long as the surface is closed, it's a legitimate solid. So I'll show some of the examples of those, and what they look like in FME. So here we have creating a box, we're creating an extrusion, we're creating a BREP solid. Actually, we're reading a BREP solid from an FFS file.
That came from IFC originally in its life. Yeah.
And we're also reading a multi-solid to just show you what a multi-solid is. So let's run this quickly.
So in some cases, you're making objects out of thin air, and other ones you're reading them. Whoa, they're all on top of each other.
Yeah, that's okay, because we've
hey, my teapot, should I sing again for you?
No, please. Okay, so there's our box. And you can see it's, well, a box.
It's nice and boxy.
Yes. There's our extrusion. And if we look at it, and more importantly, if we click and look at the feature information window, we'll see FME extrusion. We'll see it has a base face, and it has an extrusion vector. Now, this extrusion vector does not have to be the normal of the face, so this can be actually off on a sort of skewed angle and stuff. But ultimately, yeah, you start with a face, or FME's actually, the extruder in FME's smart enough to actually work with a polygon as well.
Yeah.
And you give an extrusion vector, and boom, there's your solid.
So this one's going straight up, basically. Is that how I read that? 0, 0, 30. It's 30.
Yeah,
30 straight up.
30 straight up. So that tells you also the depth of the extrusion.
Yeah.
Okay, you can see through it and everything. Now, the next is the BREP solid.
You know what that looked like, Dave?
A pipe?
No, it looked like the Doomsday device from the original series.
Okay.
Let's see if anybody at home knows what I'm referring to.
Okay, so there's our teapot. You can see it has an outside surface and an inside surface to be a true solid, as well as some bounding surfaces there too. If we took a look at it in the data in the feature information window, Okay. So here's our BREP solid. That's the header. It's got as its children composite surfaces, a composite surface. And the composite surface actually has children of its children are composite surfaces. So you can have a composite surface that's made up of other composite surfaces as long as they all edge join and face the same way. And again, the composite surface is made up of faces and down to the polygons, etc. Now for another one, this is a multi-solid. Essentially, a multi-solid is two solids that, so this is one feature even though it doesn't touch each other. So we have a multi-solid, it's made up in turn of BREP solids, which again in turn is made up of composite surfaces. Sorry about the toilet, folks. I've been doing some home renos lately and it's on my mind.
But you know what? I think that every IFC file always has at least one of these.
One would hope.
It seems like the most popular IFC object.
So that's essentially the solid. So now we sort of covered the basic geometries and what they look like. Let's see what we can do with them. So now we're going to dive a little bit more into the structure of the geometry. We've covered this a little and showing you in the data inspector there. But essentially, we have like multi-level geometry structures. There's a hierarchy involved, and that hierarchy is reflected in the geometry. All of those levels can have their own individual names. We can have what we call traits on the geometry, and a difference between a trait and an attribute in FME is an attribute sits at the feature header level. So if you have a line, it has attributes. If you have a polygon, it has attributes. But if you have a like this multi-level geometry, like say you get from a SketchUp file, in a SketchUp file, say each layer of the geometry can have its own, well, I guess layer name. And we can do the same thing in FME by assigning names and attributes to each layer of that geometry. And those we call traits to separate them from attributes. The other thing that we can do is sometimes it's very useful to be able to manipulate this geometry without extracting it from the aggregate or the hierarchy. And we have, some of our transformers have a thing called geometry query. And this allows us to specify what part of the geometry we want to manipulate. So let's take a look and see how we can do demo some of that capability. So this is going to read a SketchUp file and just show it to us, and we can sort of walk through that geometry. So we have our SketchUp file. We zoom in. It's a happy little house. We click on it. We see the whole thing lights up. Now, a lot of the 3D formats, with the exception of IFC and City GML, we read the entire model as a single feature. And that retains the entire hierarchy of the model. So in this case, we've read everything. Every part of the house becomes part of a single feature. And this is an aggregate feature. It's got more aggregates as we go down. It's also got a thing called geometry instance that you see here. And a geometry instance is a way of storing a geometry, a repeatable geometry, like say a door or a window that is always the same. Store one definition of that and just use it in multiple places. Now in SketchUp, that's called a component, and this is actually what this maps to when we read it right to SketchUp. But it's very handy, and we'll show you why it's handy a little bit later.
I think we've seen examples, like a bridge where every bolt is one of these instances.
Exactly.
And so it can be done quite efficiently, whereas if you actually explode out those instances, you would get an enormous ballooning of data volume.
Yeah, foreshadowing, folks.
But this is kind of reminding us about the importance and the difference of true 3D data compared to traditional 2D data. Traditional 2D, we do not ever really have this type of hierarchy. It's extremely rare. Yeah. Maybe some small world friends might have seen some of this a little tiny bit. But that's why really digging in and rolling up the sleeves and working with complex 3D data requires a different tool set and a different set of understanding than traditional 2D. So Dave, you're going to teach us even more, I bet.
I hope so. Okay, so here we see, if we look up top, we see our standard attributes up here, dimension attributes, base name, data set, etc. But here we see that each of these aggregates has the traits. So in this case, it's the SketchUp information. More importantly, you have the SketchUp layer name. SketchUp is hidden inherent material. Now these things all apply at the different levels of the hierarchy. And if we open one up a bit, there we go. We see that there are traits here as well. So there's different layer names as we go down the hierarchy, and different information as we go down the hierarchy. And a lot of these 3D formats allow you to store information like that, and the traits allow us to represent that and save that in FME to make that more useful. So now we want to work with some of this geometry. So I'm going to show you an example of the geometry query. And we have a handy little transformer called the geometry part extractor. And this allows us to extract part of that geometry while leaving the rest intact. And you see it has here the geometry X query.
And so this is a language that's based on the actual X query of XML,
Yep.
but extended to help us manipulate and dig into the bits and pieces of FME geometry.
Yes, exactly. So we have a series of ways. It's kind of like the standard tester. You can have several tests. And you can have the test clauses. The test clauses, we give you a little building box, much like the tester, to build them, except it's a little different. We can choose this part, which is kind of standard. We can choose the parent of this part, the ancestor of this part, the child of this part, or descendant of this part.
That's who are we going to test?
Exactly. And now this is not what we're going to extract. This is what we are going to test. So if we want,
yes,
this part is kind of always what we will extract.
That's me. Yeah, that's the thing that would come out if it passes.
But if we want to test, say, I want the part whose children are all on level such and such, we can do that as
yes.
well. In this case, we're going to just stick with this part. There's a bunch of things we can test. We can test your geometry name, your geometry type. We can test traits. We can test geometry definition reference, and that's the pointer to an instance. Trait storage type. We can test on appearances, and we can also test on hierarchy. Generally, I find that geometry name, geometry type, trait, and hierarchy are probably the most useful. Hierarchy is good because let's go all the way down to the leaf level, or let's apply something at the root level. That's where that comes in handy. So we're just going to go with trait for now. And the trait we're going to work on is...
We didn't actually talk about that, but inside FME, we throughout all the geometries, we have this concept of traits, which are like attributes, but at the geometric level.
Yep.
And that becomes important in these complex nested things, because it means you can have attributes that dangling all the way down there. For a GIS person, we can, let's say you had two original lines, you wanted to join them into one longer line, you could put traits on each piece of those that were different and have a path. That's in sort of 2D world, but in 3D world, it gets much more complicated.
Yeah, so here we're going to extract, we only want the features on the second floor. So we're just going to make a simple filter. We want geometry trait SketchUp layer name equals second floor. We can negate it if we want. And you see it gives you the X query preview down here.
Do you know what I'm told that's called?
G, yeah,
the G string. We're not going to say that's called the G string?
No, no.
It is.
This is a serious webinar.
Okay.
Okay. So and you can actually create these X queries in like free form if you want. You can switch to the advanced mode, and then basically write this off. Personally, I find that very hard, and I'm supposed to be an expert. So generally, I tend to stick with the interface here. Maybe you can tweak a little bit once you've designed that, but
you want to just show them what the advanced one looks like. Yeah, here we go. It's going to be okay, Dave.
Okay.
Because people, like, if you open up the accordions on the left, when you got test clauses and things like that, see, you can actually drag these out. And if you know what you're doing, basically, if you're an X query type of person, then you can start dragging this stuff out and do quite like unbelievably complex stuff. But I guess you've always been satisfied with the simple mode.
Generally speaking, yeah.
Oops, I've kind of goofed you up now.
That's okay. I've done this.
So let's see. He's going to go for this part. And looking for a trait, and this is the part where he has to remember what it is. It's the SketchUp layer name. Okay. Second floor, right?
Yeah.
All right.
Unlike some of my webinars, I actually rehearsed this one.
All right.
Okay, and then the action in this case, we're going to extract it. So we're just going to discard everything else. We're just going to grab the second floor.
What other things could you do there?
Just extract and
delete, maybe
remove. Yeah,
remove.
I'll show that in the second one.
Okay. So there it goes. It's done its thing.
Yeah. So here we see that. Whoa, we have just the second floor.
Very, very powerful if you know what you're doing. Like that's incredibly powerful what you
Yeah.
just did there.
So this is just a basic extract, and because we're extracting it, we actually get single pieces. It doesn't sort of retain its aggregatedness
Okay.
on the extract, because we just basically said grab every feature that's has a name second floor. So
Yeah.
it goes to find the first one, finds the second one, but it doesn't keep the hierarchical structure.
It threw it back into an aggregate, but we lost the nesting.
Well, these parts are aggregates because on this case, the layer name is second
Oh,
floor.
I see. There.
So it keeps the geometry
Sorry.
that's on the second floor.
I can tell for those that are new to the data inspector over on the left, that tells me there's 17 features up in there. And so there's 17 pieces were extracted. Got it. 17 separate pieces.
Yeah. And the alternative one you can do with this, if you just want to get rid of the second floor, you can just set it to remove, and we'll run that quickly, and we'll show what the output of that is. Okay, so now we have the original model minus the second floor.
Whoa.
Yeah, your building inspector is not going to like that. But the interesting thing is here is that we still retain the aggregate hierarchy.
Because there's only one feature on the left-hand side.
Exactly.
I see.
We've removed the second floor.
Yes.
But the main feature keeps its same
Got it.
hierarchy and its connectedness and everything. So that's the part extractor, and that just shows you some of the tools you can do and some of the things you can do with jQuery.
Yeah.
Other things that have the jQuery are like the appearance setters and that sort of thing.
It kind of finds its way through a lot of these
Exactly.
transformers that allow extremely powerful manipulations then.
Yeah, and anything that where you think you're going to be dealing with a hierarchical type feature. Now, speaking of appearances, let's have a look at some of those. So appearances, there's two types of appearances that we can deal with. And appearances essentially is what the 3D object looks like. Essentially, we have a choice between setting the color on the 3D object, and we showed some of that before. You can set different types of diffuse, ambient, emissive, alpha. Emissive colors, you can set an alpha value. Alpha value is nice actually when you're designing something, you can see through it a little bit, so you can see the inside as well as the outside. And we also have textures, and now texture is like an image that's being draped on your 3D object. And we'll show some examples of that as well. So we're going to pop back one workspace. We're going to look at the colors first. Now you notice that when I ran the workspace to show you all the solids, I had these geometry color setters in here, and that's how they all came up into different colors.
Okay.
And if we look at the geometry color setter, now this is a really quick and dirty way and very, very simple way of making your 3D stuff have colors. Quite frankly, the easiest way to do it. It's the way I always use. So you have different types of color generation, fixed or random. Random makes it look very sparkly, but it's a little confusing. Fixed allows you to choose a color from your color chooser. And it gives you the color down here. The other cool part here is alpha. Now this is very handy, especially if you really want to see what your 3D data looks like. You want to see the inside and the outside. You don't want to have to zoom inside and look around. If you set an alpha 0.5, you make everything transparent.
That's how you can see. Someone was asking earlier when we had the Doomsday device up there, how you had made it able to kind of see through so you could tell where the boundaries were. Exactly. And that's the key. Yeah,
and if you're messing around with 3D and you know you just want to see what your model comes in looking like, and you want to see the interior and stuff, throw up a geometry color setter, set the alpha to 0.5, and all of a sudden, boom, on the output, you can now see what everything looks like, and then just get rid of it later when you're done. So that's a geometry color setter, and I think we remember, if we pop back to what that looked like. Yeah, we have, we can see the inside and the outside of everything here, right? So we can see through it, which is kind of handy. So that's basic color setting. Now, for more complex colors, we'll get to the textures. And textures are kind of interesting because essentially you have this thing called a UV mapping, which is how you map the pixels of the texture to the actual 3D geometry of each face.
It has nothing to do with ultraviolet light.
No.
Okay.
Now, there's all sorts of funky math in this, and I had to learn it once, but luckily we have tools that we make you not have to worry about that. So let's go into our next workspace, add texture 1. So we have the appearance setter, and the appearance setter is your basic mechanism for applying textures to a 3D object. So here in this example, we have an orthophoto. So we'll just have a look at that quickly. So this is Molokai, the island of Hawaii, and then I forget the name of this island, but it's a fairly big area of land. And we also have a surface. And this is the island of Molokai itself. And you notice the difference between this is basically one island. If we skip back to here, the orthophoto is one island, a bunch more information. And what we want to do is use this orthophoto to texture the model of the island. And what I'm going to do quickly is just give myself a little bit more memory. Okay. So we use the appearance setter, and the appearance setter has a lot of things that you can play with, but it basically breaks down there to fairly simple once you know what you're doing. So we have our geometry X query again. And now if you leave this blank, essentially it's going to apply this appearance on each level of the hierarchy, and you probably don't want to do that. So what we do is I have a different query that says, we're going to test this part, we're going to look for the hierarchy position, and we're going to go for the root node. So we're essentially going to apply this texture at the top of the hierarchy tree. And then it'll percolate down to all the rest of them automatically in the rendering. We're going to set the appearance on both the front and the back. Appearance storage, we're going to create new definitions because we don't have any definitions yet. The more important part of it is if we open up the texture coordinate generation parameters, we have the texture mapping type. And now this is the key, real key part to the appearance setter. We have several options here. Surface normal, which means that the texture is going to be applied as if you sort of stuck it as a sticker onto the face itself, and you stick it straight down, and the next you stick it straight down. So regardless of which way the face is pointing, it's always going to be applied sort of like a sticker. From top view is we're going to apply the image as if we were looking down onto the surface. So basically down along the Z-axis, and if there's a lot of vertical in the face, the image is going to kind of get stretched out along that vertical. So it's not as a sticker, it's kind of like if you're projecting an image from a slide projector down onto the surface. So those are kind of nice, but the really cool ones is top-down georeferenced.
Whoa.
Yeah. Now what that says is we're going to take that same slide projector top-down, but at the same time we're going to use the georeferencing of the orthophoto to color only the faces of the surface that fall within the ortho. So it sets up your whole texture parameters thing and automatically drapes it properly in the right location. So quite frankly, this is the one you're always going to want to use.
If you're the least bit of a GIS-y person.
Exactly.
But I mean, the other ones would be useful if you really had no coordinates and you're managing, or no coordinate reference system.
If you're just going for a pleasant appearance rather than a realistic appearance.
Right. If we're putting like bricks on a wall or something like that, then we don't care about georeferencing. Yeah. But this is what the key would be for a real path.
Yeah. And for some fun on the output of this, I'm going to write this to cesium. And so you all can look at it. I'm going to use the feature writer to write this to cesium. Now, I don't know if anyone's seen the feature writer before, but basically we're wrapping all of our writers into a transformer. So we can write this out to a temporary location, which I'm doing here. I've got the cesium 3D tiles, and back up a bit. I've created a temp path name creator. Now this is kind of cool because this creates a temporary folder on your system that gets deleted and cleaned up whenever the workspace finishes. So you don't have to worry about cleaning up after yourself. You want to use one of these temp path name creators. You throw whatever you want in there. As soon as the workspace shuts down, we delete it all for you. Right. So we've created a temporary folder to write this to. In the feature writer, we're writing up cesium tiles to this temporary folder.
Yeah.
And then our last step is to use an S3 uploader. We are going to upload this to S3, where it's going to sit there, and there's actually an HTML page that sits up there as well that you guys can access, and that allows you to see cesium, because cesium is pretty much a web format.
Right.
So if we click on this, and you guys are free to click on that at home.
Let's see, can Stephanie just...
Stephanie...
Rats.
Oh, I know what I did. This is Windows. Don't do this.
Don't do it on Windows.
Don't do it on my Windows.
You do need to select that.
Yeah, I do need to. Don't do it on my Windows machine because it's a VM and it doesn't have any 3D capabilities.
Oh yeah, you don't have 3GL.
Control still, you see,
or WebGL going. All right, so you're gonna have to
exit. I'm going to click
I don't know if we may want you to actually put that into the. I don't know if Stephanie, do you have the power to
post that for everybody?
I don't know if she does.
I can do it here.
Yeah, why don't you do it, Dave? So go down there, entire audience. Go ahead. Boom.
There we
Okay.
go. So everyone can go play with it now. And if I get boring, you can look at this and spin around.
All right. So where was it? So
there we go. So
now,
there's our cesium. We see it's located, and this is the nice thing about cesium, unlike the 3GIS, it's actually got a world location.
you got context.
Yeah.
Okay.
So I can spin this around.
Everything else is flat as a pancake.
Yeah, everything, because that's just the Bing Maps location.
That's a 3D. It's not even a 3D pancake. You've made a 3D pancake.
Yes, I have a 3D pancake here. That for some reason it's not as pretty as it was yesterday. But let's zoom in. Oh, different time of day. That's why. It's still not morning in Hawaii yet.
Oh, what is it using the real time to light this baby up?
Yeah.
Wow. Do you have the power to change time?
Oh yeah.
Whoa.
Cool. This cesium stuff is cool.
So it's actually showing us what it would look like if we were there.
Yep.
So we don't need to go to Hawaii anymore.
I'll go to Hawaii. So yeah, and then so we can see the texturing, and it sort of shows up, and you can see that it all maps properly. It all lines up with the map that's actually there. So our ortho-rectified image has been properly draped on our model.
Yes.
Okay.
All right.
Okay, let's get back into the slideshow. Okay, so we've covered that. We've uploaded it and everything.
For those that don't know, S3 is Amazon's storage system, and FME is a very convenient way.
Yes.
You can publish stuff up there, and if Dave you must have ahead of time set up that bucket correctly so that it will publish or let people hit it as a web
Exactly.
address.
So it's all public. So we can upload it, and with cesium, the cesium model, so far I haven't found a very good viewer for it. So we use the cesium JS within a web page, and that's why we give you this link that there's a HTML web page there, and that's what you're clicking on, and that allows you to see the model.
Right.
Okay.
Awesome.
So, oops. Next demo. Okay. Kill the cesium window. We're going to kill my cesium window. Okay.
There we go.
Okay, so we've made things a little easier on my computer. Next step. Now we have a different. No, this is like I said. We've dealt with the appearance setter, and that's the easiest way to set the appearances on your 3D objects. But there's another way, and this will be that we're going to cover, which is the shared items. Now the shared item adder is another way, and I'll explain a little bit, is that the textures are stored within FME in a library. So we have a library of your textures, and we can, as you can see, we apply them to multiple faces, and each face has a reference to its texture. Now, these are this library of shared items essentially can be accessed through the shared item transformers.
And is this also where instances live?
This is also, we'll deal with instances in a bit.
Yeah, we have fans at home who are excited about instances, Dave.
Okay, so in this case, we take the same ortho photo, we take the same surface, and we take the shared item adder, and what we're going to do is we're going to check this ortho photo into the shared item library. So we select item to add as a raster. Its insert mode is add new item. We also have a replace existing item. I'm going to show you that a bit later, where you can actually update your rasters or your textures, and that's actually a quick way of updating textures or even instances. And once it checks it into this library, it creates an ID for that, and on the feature that's returned from the shared item adder, it's going to put the ID of that texture in an attribute for you, so you can use it. So next is we're going to take that attribute and merge it onto our surface. So now that the surface knows what texture we want to put on it, and then we have the shared item ID setter, and this is a little bit like the appearance setter. We have the item type as the raster, again front and back sides. And down, again, we have the texture mapping type. And again, we're going to pick top down to your reference.
And I can see that geometry part selection must, by default, it's a G query that says, let's just take everything.
Yeah, well, actually, in this case, I say let's just do the root node.
Oh, just the top. Okay.
And actually, I find that there's some issues actually in Data Inspector, and if you apply the textures all the way down.
Because they inherit, so the root node is enough.
Yeah, so if you set the root node, everything below the root node just inherits the root node.
Got it.
Okay. And then we'll just run that quickly, not out to cesium this time, just out to Data Inspector, see what it looks like. And there's our island of Molokai again with all the textures in the correct location, thanks to the georeferencing. So this is an alternative way. For a while there, this is the only way to do georeferencing, but we've added the georeferenced orthophoto or textures to the appearance setter as well.
Now this, if you had a whole bunch of surfaces going by, you could save or make a more efficient output by having them all reference the same shared item.
Yes.
Right.
Yep.
In this case, it was 1-to-1.
Yep. And the other bit of georeferencing, now we're going to deal a bit with the georeferencing that isn't, with textures that aren't georeferenced. But there's another thing we want to do is that we want to make things, before like we would just apply a surface, and like I said, if we just sort of paste the image to the surfaces, we would paste the entire image to the surface. So if you had a big block beside a small block, you'd have, say, if we looked at this image, which is a nice little brick texture, a repeating brick texture.
Somebody just asked.
Yeah, the big block would have big bricks, and the little block would have little bricks.
Oh, they'd be stretched to. I see.
Stretched to fit.
Somebody at home was asking how we can use these textures on buildings, and that's kind of what you're doing here.
Yeah. So what we do here is we're gonna use another setting thing in the appearance setter where we're gonna set surface normal, like we have a surface normal, but now surface normal and ground units.
Okay.
And what that says is take the ground units and apply that when you're texturing that and you're making the repeating and everything. Set that so it uses its ground unit. So you apply a size to these bricks.
Okay.
So
and they're going to be the same.
They should be the same.
Okay.
So for that, we first need to use, this is just a texture, so it has no georeferencing on it. We put some georeferencing on it with a raster georeferencer. We just set a cell spacing. So you're setting the pixel size here. This is actually a fairly high resolution image of not too many bricks.
Okay.
So we set a fairly tight cell spacing. And then we're just going to run this quickly to see what she looks like. I've got just a couple of small walls here.
All in all, it's going to be another brick in the wall, Dave?
Ooh, that's going back.
Actually, I think that guy was in town for a concert maybe in the last day or two.
Oh, yeah.
One of the Pink Floyd dudes.
Roger Waters, yeah. So if we zoom in on this.
Whoa.
Whoa.
Oh,
there we go. We see that.
It is another brick in the wall.
Yeah. Okay. Oh, there we go. We were off center just a tad.
Oh.
So we see that we have small wall over here, big wall over here, but hey, the bricks match going across.
Wow.
So this gives you, if you know, we've got you the top-down georeference lets you do the tops of your buildings off an orthophoto.
Yeah.
Now we can give you nice side textures as well that are all scaled properly. So you can get a texture, you can work out the scale, and you can apply it, and it'll look good. The other thing that it has is we also deal with, let's zoom out a bit. It also is fine with cubes as well. So it'll maintain that, because we say pick the surface normal, doesn't matter which side you're looking at, it maintains that size.
So it's repeating
repeating on the
so the image is being repeated over and over again, and it's all lined up and looks great. You want to choose an image though that kind of the beginning and end seam up together.
Yeah,
nicely.
you want it. Yeah, we want seamless. You have to pick a seamless texture, but there's plenty of those floating around.
Right, right.
So that's the last, and again, that's the surface normal and ground units setting.
Super useful.
Yeah. Now, for some more fun, shared items. Now, we've dealt with so far shared items as appearances, and like I said, we can check those shared items as appearances in the library.
Yeah.
But we can also check models into the library as well. And in this case, like we showed before, it's the geometry instance.
Yes.
It points to a geometry definition, which is a model in the library. I'm going to show you how to create those.
You're gonna spray toilets everywhere, Dave?
No, we're getting a little classier now.
Okay. Okay.
So a little bit more complex. And what we're doing here is I'm going to take a bunch of, say, GIS data, which in this case is street lights. And all I have is a point location and a rotation. So this is like you'd get in your GIS type data,
Okay.
right? And the other thing is I don't like that, so I'm going to replace those poles
Got it.
with funky pole models that I've borrowed from 3D Warehouse. And literally, this is the other thing about, I want to point out quickly about the SketchUp reader in FME, and many of the readers in FME, is that this is downloading directly from the 3D Warehouse.
Whoa, there's a big long URL there.
Yeah, so I'm downloading from the URL of that model in the 3D Warehouse.
Yeah.
This makes you happy because you don't have to move it to your disk and download it, and it makes our legal team happy because we don't have to ship you other people's models.
Right.
So in this case here, we have the model of our light post that we're going to assign to each location.
The other advantage is if somebody updates that model, then you're going to get the freshest one.
Exactly.
Okay.
So we have a few things going on here. We have the points up here. We're going to grab its coordinate system.
Yeah.
We're going to extract a location because we need that location as just a XY.
We're going to tuck it away.
Yeah, we're going to tuck it away. Now I've got two streams here that I'm doing. There's two ways of replacing this model. The first way is we're going to create a separate geometry for each pole. So I just take a feature merger and I merge the model by merging the geometry. I merge the pole geometry with the feature merger onto each point, and then I rotate it by the rotator, offset it to its proper position, which I stored in the coordinate extractor, set the coordinate system, and boom, out to SketchUp she goes. This section here, some of these people make really nice models on the 3D Warehouse.
Yeah.
But what they don't do is put them at the 0, 0.
Right.
Or scale them to what you're interested in. So this is just, I took that model, I'm just moving it into the right scale, I'm rotating it in the right way, and moving the right place, rotating the right way, and making it the right size for our demo.
Because these instances we're going to place are going to be wanting to be centered at 0, 0, basically.
Well, yeah, at that. So we want to make sure they're centered at that point.
At the insertion point.
Yeah. So now in the instance geometry, it's a little bit more complex here, is we are going to use the shared item adder here to add this pole model as a new geometry definition. So instead of before we did the raster and texture appearance, now we set it as a geometry definition. We want to do add new item because we want to check a new definition into the library, and we want it to return the shared item ID. We want that ID of that item sent back to us. So after we've checked it in, the feature is going to go, now has this new attribute, the shared item ID. We're going to use a feature merger to merge that shared item ID onto each point. And then again, we use the shared item ID setter, much like we did with the text string before, to set its geometry definition to that ID. So now it's replacing that point geometry with the instance geometry, which is a pointer to that feature in the library. And again, we rotate it to get it into alignment, and we set the coordinate system on. So if we run this quickly, and again, this is pulling off the, actually downloading and reading that file. So here are our outputs. We have the street light with instances, and we have the street light with the separate, both in SketchUp file. If we look at the sizes, the separate, each pole being its own separate geometry makes the file 2.3 megabytes for like 9 points. Whereas if we use an instance, that pole only gets defined once, and it's only at 277K.
Wow.
Yeah, so it's nice and lightweight. If we look at it in SketchUp, we can see there all of our beautiful light poles.
Yes.
And if we look at it here, we see that it's a component. So each one of these is a component. So again, in SketchUp, it's only been defined once.
Yes.
And these are just locations and rotations of that one particular model.
Very common trick when people have GIS data with a bunch of points where something interesting is, and they want to render trees or whatever it is.
Exactly.
You want to be doing this kind of thing.
Yeah, and we can also see that we've got the geometrical or the geographical location on the SketchUp.
That's somewhere nearby, I think.
The lat long, yes, very close. Vancouver, I think, is where I borrowed those points from.
Yeah.
So now that's good. We've created these. We've created all these light poles, but that's kind of a boring light. I think we need a snazzier light.
You're gonna spiff it up?
Yeah, let's spiff it up a bit. So we're gonna do the next workspace is we're gonna.
That's the last workspace.
Yeah, the last workspace. We're gonna update those instances.
Ooh.
Now, rather than replacing each pole, what I'm gonna do is something sneaky. I'm gonna go in and I'm gonna change the definition in the library.
Whoa! On the fly.
On the fly. So here we go. That's our old pole. That's our old pole models. This is our new pole. Let's see if we can take a quick look at it.
Whoa.
Oh, it's coming. There we go. So yeah,
Oh.
that's much cooler.
Yeah, it is.
Yeah, we like this one.
Gas Town.
Yeah, yeah. So again, not in the right place. Offset, scale, rotate, etc. to get in the right place.
Yeah.
But now we're doing something a little different. So we read in the original streetlights. Now SketchUp, like I said, is read as a single model, but we want to break out these street lamps into the individual parts. We could use a geometry part extractor, but in this case, I know it's the next level down of the geometry, so I just use a simple deaggregator. So I send a copy of it to the shared item ID extractor. So that goes in and goes, well, you're an instance. What's your shared item ID? What's the ID of that location in the library? And it's going to put that on the shared item ID attribute. So then I merge that shared item ID attribute onto the pole model. So now out here we have the new pole, and it knows what the shared item ID of the old pole is.
Okay.
So we then use the shared item ID adder. In this case, we don't add new item, we replace the existing item.
Got it.
And we know what the shared item ID is because we got it from the feature merger.
Got
so we
it.
know which one it has to replace, and we're going to do that.
So you're doing surgery on an existing SketchUp model.
Exactly. Now that's done. Now this is a little bit tricky in that FME generally works sequentially. So it reads a feature, writes a feature, reads a feature, writes a feature, reads a feature, writes a feature. Now, if we write the features, the lampposts, before we check the new definition in, it's going to be written out with the old definition.
Got it.
So what we want to do is we want to hang on to all these features and say, hey, wait until I've checked in the model, the new model, and then we're going to write you out.
Right.
So I send both the model and the features to a feature holder that just holds everything till everything's gone through.
Yeah.
Then I have a tester because I want to get rid of the model. We don't want to write the model out because it's being written out as the instance on the other place.
Yes, I was going to ask about that.
Yeah, and then we write it out to the new SketchUp model.
You just need the feature holder to hang on to everything until the bitter end.
Yeah, and now I'll show you something quickly. The appearance setter has actually this holder port.
Yes.
And that's what that holder port is for on the appearance setter.
Yeah.
So if you can just send the copy of your geometries into the holder, and basically this won't be done, or all the features won't be output until all the features have come in.
Right, and then you can output them afterwards. Just hangs on to them.
We don't.
So bottom line is order is important when you're dealing with these shared items. You got to make sure that they're all set up before your writer starts doing its work.
Yeah. We don't have a holder port on the shared item adder, but I believe that's coming up maybe 2018, 2019.
Okay. Yeah.
Okay. So if we run this quickly.
While it's running, I can think of another way, Dave. If we would have had a null writer as the first writer, and then the SketchUp writer is the second one, that might do the trick.
Yeah, that would do the same because then we're using the writer infrastructure to essentially hold stuff for us.
Yeah.
Yeah, because when we write out sequentially by writer, so the first writer gets written and the second writer gets written. So if the features come in willy-nilly, all the ones from the second, third, and fourth writer basically get held and cached. Yeah. Until it's their turn to write.
Someday we may have an option there, but for now that's how it works.
Yeah.
So what has happened? So
if we look at the updated SketchUp file.
Oh.
And lo and behold, we've done it. Oh, fancy new lights.
All right.
In the same places as not so fancy old lights.
Right. So we did some instance surgery.
Exactly. And again, these are still components.
Yeah.
We click on that, we see it's a component, so it's still lightweight. Although this is a much more complex model, so the size does go up a bit.
Right. All right.
So that's pretty much the end of all the demos. These are the transformers that can deal with the sort of 3D objects we've been working with. There's creators, face replacers, extruders, etc. Things to create features. You can modify features, set appearances. Now the instances we have is separate, the instantiator, and I believe one of our VARs offered a beer for anyone who can explain what the instantiator does. So I'll give it a shot. Essentially, for some formats, you don't want things instantiated, or for sometimes when you're working with data, you don't want these pointers to instances. So all the geometry instantiator does is it replaces that pointer to the instance with the actual model itself.
So you're basically like a Xerox copy. You're actually creating actual instances, or you're materializing them at each place.
Exactly.
And copying them over and over again.
Yeah, but however, that said, anytime if you make any modifications at the instance level, say using a jQuery that makes it different from the library,
Yeah.
we will automatically instantiate that for you anyway.
Right.
So that's something to actually be careful of if you're messing around inside the instance, and you want to do, if you do it through on the feature itself, you're gonna uninstantiate, or you're gonna instantiate that instance. You're gonna bring it out of the library and make it not a library reference if you change it directly. So you might want to look at the difference of changing it on the feature or messing around with the library itself, depending on what you want to do. And then the shared items, again, shared item adder, retriever, ID setter, and ID extractor. And then for working with structures and traits, you got the again, geometry part extractor, geometry property, etc., extractor, trait merger, etc. And turn this over to Dale to explain Dimitri's workspace.
We're actually out of time. So what I'll do is say to folks, if you want to head off, you've got to go to things, we want to thank you very much. Dave and I will hang around a little bit longer and kind of dig into a few things. There's a few folks asking some interesting questions as well we'll dig into. But we do appreciate your time. We hope you enjoyed this deeper dive. And you can always live chat us afterwards. Dave, some folks were asking, are these workspaces going to be made available?
Yes, they will. And as much data as we can will be made available. Like I said, most of it is pulling directly off the 3D warehouse. So that makes it simpler. That's
right. So yes, all this stuff's available. Some folks asked, can we do this kind of stuff with CityGML?
Yes, we can.
Yeah. So this is really meant as kind of an introduction to the building blocks for really rolling up the sleeves and doing stuff powerfully with 3D. Yeah, here's a bunch of resources. Again, these slides will be made available as well. Oh, there's actually a whole tutorial there, Dave?
Yeah, that's the basic 3D tutorial.
Yeah.
And then from there's links to other 3D information as well.
Yeah.
And then these are the demo models I used and their acknowledgements where I got them from.
So anyway, thanks folks for tuning in. Dave and I are going to hang around and look at a few more things, but if you have to run, we do understand. So we'll see you next time, and stay safe out there on Halloween. Okay, so let's go back to Dimitri's example just to take a look. And I noticed that we did kill off our servers, so we long for the day when we have elasticity in our servers, and that's coming.
Is that what happened?
That's what happened. So if people want to go to FMELY Pumpkin, if you kind of take your turn and line up, it'll work just fine. But I'll just talk through this a little bit. What happens is that when you enter your text, it starts off with this creator here, and then immediately we deal with creating the text into 3D objects. So that's going on with that text stroker business right there, the text stroker Dave's pointing at. And then we extract that, and now we've got ourselves the text. And then we have to also clip it to be sure that we're not going outside of the pumpkin itself. So that's what's going on with that spatial filter business. And finally, we orient it and force it to 3D and extrude it. Ultimately, I guess we have to calculate normals to extrude as well for that text. And get it into the pumpkin. And now then we're ready to clip. And so all we're doing in the clipper is taking out, the clipper is the text you had, and the clippy is the pumpkin that's been read in from our feature store. It's pre-carved with an FME logo in the back.
Okay.
So that's what's going on with that. And so then we take the stuff that's outside of the clipper. So that's why the outside one, we don't want the actual, the bits of pumpkin that you'd use to make pie, which actually would be what your letters were. Yeah. That would be the stuff that's inside. And then we just set it to a nice color converter and use your appearance transformers to set up the look of that, of the whole thing. And then ultimately we create 3JS and output it. And so that's how that works. Again, if you want to try FMELY Pumpkin, you can go ahead. Let's see what else people are asking. They want the workspaces. Lots of people that are interested in trying to go to CityGML.
Okay. One thing I'd point out on the pumpkin demo is that the clipper does not currently clip surfaces. It does, however, clip solids. I know that's a little strange, but we can clip solids by solids, which is what this pumpkin carver is doing. Okay. And that's basically we're applying a constructive solid geometry to do that.
Great. Yeah, that's right. We didn't actually talk about that. Constructive solid geometry, CSG.
Yeah, generally you can use CSG, but we try to use that where we can under the hood, where to wrap it in transformers, like the Clipper uses CSG. Creating features from CSG where we lack a lot of, like I said, our only primitive is a box.
Right.
So it does get kind of hard to build up from CSG, and that's a whole different.
But I think a lot of IFC comes in as CSG.
Yeah, it's used under the hoods to build up
Yes.
from IFC.
Right. Okay, so yeah, that was really all I wanted to talk about there, and you can go ahead and try this throughout the day and see if we can bring down our server again. I can't wait. Like a year from now, we're going to have Docker-based elasticity underneath there. So if we have 1,000 people going at once, bring it on, baby.
Yeah, yeah.
Other than Don and I have to pay at the end.
Oh, well. Yeah, what's our Amazon bill?
Don't want to talk about it?
Okay.
All right. And actually, you can download that. If you go to that Pumpkin page, you can download that workspace of Dimitri's and play with it yourself.
Yeah.
As well. So
any more questions?
Let's see. Anything else that we wanted to point out?
Do you guys
So
want
one
us to
person's
go
asking if we think that 3D WebGIS is in a place where it's viable. And I think it is. You know, the stuff I've been seeing lately
between cesium-based stuff is, yeah.
And also Esri's i3S, the Esri stuff too,
yeah.
just was accepted by OGC as a standard. We can write both i3S as well as cesium tiles to some degree, and there's work ongoing there. I know there's something called GLTF.
Yeah, that's used within cesium itself.
That's right.
Too. Yeah. Yeah, I know with cesium, I'm assuming the Esri one as well, that you can actually put attributes on the features that go out and click on the features and get the attributes to pop up. I've seen that in cesium.
Yeah.
So yeah, this does give you a whole GIS sort of viewing interface anyway.
Right. So it's not that hard, and we want to do more with 3JS in terms of making that a little bit easier. You can certainly use these examples like Dimitri has created there. It's a bit quirky to get 3JS to output. Right now we're doing with a custom transformer in his example down there.
Yeah.
So you can grab Dimitri's and look, but it's amazingly powerful. We've been working with Safe is Moving Offices, and we've been working with our architect related to that, and taking some of the building models from Revit and going out to 3JS, and it totally democratizes wandering around inside of it. I could also talk a little bit about the future. We're working with the Apple AR kit to do some augmented reality stuff. So you can take these outputs and go right to augmented reality with that. Okay. Oh, you're looking at some
the JSON
hub stuff, or
well, no, JSON templater, I think, to create 3GS. So I think if we is there.
Yeah, how is that done?
I don't know if it's on the list here.
Maybe it's on process points or something. I don't remember. Anyway, that's somehow you can look at Dimitri's and see how to make 3JS. Yeah. Someone is asking, Dave, if they wanted to get started with texture mapping, what's your advice? Like, is there some articles on the Knowledge Center that kind of help you, or what? That 3D tutorial probably has some stuff, or where would you go? Yeah,
there is one on, well, I don't think we have one on texture mapping. The doc has some information, documentation. If you look at the appearance setter doc.
Why don't we fire it up?
Sure.
There's always risk, but let's try it.
Yep. Okay.
Actually, you can do it right from the FME there, couldn't you? Or
you could, I suppose.
You're going to say appearance. Okay, I see. He's going to go right to there. Appearance setter. There we go.
Here, appearance sort on FME, see appearances.
Right.
So there's a lot of information about appearances here. Sidedness, and again, it's all multi-level, so you can just click through the different pages so we can see what sidedness is all about. We go through the surface geometries. Hierarchical inheritances, solid geometries, etc. on appearances. And yeah, so that shows you how to work. But I'd say for appearances, the best thing is to remember is if you're rendering from the top, make sure your image is georeferenced and
right.
use georeferencing, and then quite frankly, that's easiest. We take care of everything for you.
Right.
If you want to do side referencing, again, set the size of your pixels using the georeferencer. Again, it's not really, that's more world referencing than like it's not putting it somewhere in the world, but you're just saying what size the pixels are. And then from there, use the appearance setter with the mode I showed you.
Yeah.
And then that will deal with the scaling for you. And then you don't have to worry about, like, I think in the appearance setter we have, you can really go to town with all these texture parameter settings.
Right.
This, quite frankly, I've never used this section.
Yeah.
And I've done a lot of work with 3D, but you can if you want. But really, we try to make it easier for you. And this one and this one, these two make it easy for you.
Right.
Right. That makes it. That's about as easy as possible. I would recommend just using those.
Somebody's asking, what about last files? How would you? What if you had a bunch of last files and you wanted to go to something 3D? What's the set of steps, Dave?
Tin generator.
Right. So that thing will take a last file in as the points or lines.
Points and output you a mesh surface.
And then you can use the appearance setter with a georeferenced image and slap. You've got yourself that Molokai thing. Yeah.
Actually, there's a cool thing is that if you have colors on your point on your lattice points, you can also use the image rasterizer.
Oh yeah.
And set a decent. Now, what you want to do is, and then some of your point file, you'd go into points lines. You'd also go into the image rasterizer. Yeah. And that would extract the color information off of your point cloud.
Yes.
You want to make. This is the part where you got to be careful. You want to set the rows and columns, or you can actually cell size is easier. Set an XY spacing that is bigger or larger spacing than your point cloud, because you don't want any holes in that image.
Right.
And so it might lose some of the resolution in your image, but you're using it as a texture, so it doesn't matter.
So in other words, if you think the points are roughly half a meter apart, then go for 3/4 of a meter or something.
Yeah. Then you can just use the appearance setter, use that new raster you've created as appearance, the tin surface as geometry, and that raster you created will be georeferenced.
Yeah.
So you can set this to top-down georeference.
Right.
And then what you get on your output is a surface model that's being textured that looks like your layers with the colors.
Right.
So
if you had other vector data you wanted to lay into there, you could use a Mapnik rasterizer to do some fancier styling. And I've seen Dimitri do that kind of thing before too. So that does kind of higher end rendering, and that thing will come out georeferenced as well. And then you can use that to slap on top.
Yeah.
In fact, you could chain these, because you could make sort of the background image with the image one, and then connect that guy in as sort of a background layer.
Exactly.
And then bring in some other vectors to lay on top.
Yeah. Yeah. So you can make a really nice textured 3D output.
Yeah.
And right up to cesium. Or what was the other one for Esri?
i3s.
i3s.
Yeah. Someone was asking if we write to cesium, if there's a 3D object, does it go out as GLTF? And the answer is yes.
Well, it goes out as a cesium package. If you start cesium as a cesium package, so you've got the JSON file, you've got the data. Inside the data is I forget the extension, but it's not a GLTF. But inside of that, it contains the GLTF, as well as it contains. It's kind of like a package format. It contains the GLTF and the JSON attributes.
Is GLTF actually also a native writer? Can you just type GLTF?
Yeah, we can.
That just makes one of them. Yeah. Right.
Yeah.
So probably not that super useful. Normally it's used as a building block.
Yeah, yeah. But if you just want to write to GLTF, say you've got another process on the other end that you're using to build more complex stuff, you can go to GLTF instead.
Let's see. People are asking, what about integrated mesh scene layers? Oh, that must be i3s. Yes.
I don't know that. I plead ignorance on that.
Right.
Right.
So the answer is, I don't think, if you type i3s, I don't know that we have a writer in. No, not yet. Not in FME 2017. I should go to fire up my FME 2018 and take a peek, but
I think I have that.
I don't remember if it's been checked in yet or not, but I know we're working on it right now. So this is the time of year when we're getting excited about FME 2018. Come on, baby. I3. Yes. Well, in FB 2018, there is an I3S. If you go out onto the main canvas and just start typing, type I3S, giddy up.
Oh, there we go.
And so it could probably even, does help even work? That's impressive if it does.
Hey,
no, it doesn't. Anyway, so that means the help isn't hooked up yet for that one. But I think that might be what Mark is getting at. And so, yes, we're working at it. So let's see, what else are people asking? We might be almost done here.
Dale?
How do you control that the surface is wrapped correctly all around the rectangular box? Like, in other words, when it goes around the edge, can there sometimes be a gap there? Because I think it might, right?
Yeah, it won't. It gets applied on the face basis.
Yes.
So yeah, if you're working with a cube, a solid, it might be a little tricky to
You
get that
need
lined
to
up.
have the size of your solid be a multiple of the size of your raster.
Yeah.
And then it would be okay.
Yeah.
And it would wrap. So if that's important, you got to adjust your raster to allow that to happen.
Exactly.
A bit tricky, but yeah, that's the only way we can win there.
Yeah.
Let's see.
And that's one where, I mean, you might want to also play around with, again, applying the appearances using gQuery at the face level of the solid if it's a BREP solid.
And apparently we didn't actually invite our panelists, Dean and Mark, to chime in that are there, but apparently Dean has been begging us to answer the question, how do you generalize stuff for 3D?
Ooh,
not really right now.
Not easily at the moment, no.
Yeah, so we don't have a great solution for that. That said, we're looking at working with a few people to help with that, and we've actually got some great staff lined up that are going to be working on that over the next year and a half. But we do know that it's a common thing. You've got this detailed 3D data. You want to write that out so when you're zoomed in tight, it looks great. But if you're zoomed out, you got a problem.
Yeah. Yeah, the generalizing, that is not an easy one.
Yeah. So I think maybe we'll call that good. I think I want to go out for some 3D pancakes. How about you, Dave?
Yes, with some syrup.
Would you like some syrup? All right. So I think with that, we'll thank the 100 or so of you that have stuck us out to the bitter end. Wow, almost 150 people.
Yeah.
So thanks everybody for hanging around till the end, and enjoy the rest of your Halloween. I'm flying today. You think today's a good day to fly on a plane?
Sure, but not in that suit.
You think I shouldn't wear this in?
I'm pretty sure I shouldn't wear one.
Probably my my communicator pin might cause me trouble.
Exactly. Does it have airplane mode?
It only has a starship mode.
Okay.
Okay. So thanks everybody, and thanks for tuning in. And until next time, happy FMEing.
Happy FME and happy Halloween.
Happy Halloween.